everyone. Hope you all are doing well. Today, in this video, we will understand some terminology commonly used training model, practically, especially using the Python and sklearn. You will encounter the term like the training data set, test data set, validation data, and also we will understand the overfitting and underfitting, bias and unbiased, bias and variance. So, this video cover all these specific topic. Let's consider uh, the data set with around the 100 data point data set which 100 matlab, thousand of data set. Let's example we have the thousand of the data point, and regardless of the number of the feature, suppose this is the entire data set available. Okay, you want to train the model on it. For example, let's example we have the data set and we are planning to training the data set and also test the data test the data set. So we have the, for example, this could be the house pricing, and we have the feature like the size of house, size of house, number of bedroom, also price of house, right? So what we are doing, this is the first step of training a model, is the split the data into the two part. We are splitting the data into two part, that is the training data set and another one is test data set. Split the data into two part. For instance, you are using the 700 record will be the training data set and 300 record is with the test data set. This division help us the train the model and evaluate is the performance on unseen data, right? Which is a crucial understanding if the model is is model is overfitting or underfitting, right? So we will discuss what is overfitting and underfitting later. So first we are discuss the training data set is used for train the model, while the test data set is used for the test the model. Train data set is further split into two parts, that is train the model and the hyperparameter tuning your model. Tuning your model. Train set is used for the train the model, while the validation set is used for hyperparameter tuning to improve the model performance. Right? Understand? So combining the train and validation data help us the optimize the model. Help us to optimize model. Hope uh, whatever you are discuss. Hope all the concepts are clear. Now let us discuss the scenario related to the model accuracy. We have the train data and we also have the test data. If model achieve the very good accuracy on the both training and the test data, it is called the generalized model. Let the train data is very good accuracy, uh, around 90% accuracy mean we are hoping at least 90%, and test data is very good accuracy. Also test data is very good accuracy, around 85%. Let's example very good accuracy. around 90%. Bad accuracy around 50%. So what we are doing? We are just if both train and test data is very good accuracy, so model is generalized model. If model achieve very good accuracy on training data but poor accuracy on the test data, so this model is known. So this type of model is overfitting. Overfitting. If both train and test data is very good accuracy, so this model is generalized model. Generalized model. Huh? If both train and test data is very good accuracy, the model is generalized model. If both if train data set is very good accuracy, but the test data set is bad accuracy, so model is overfitting. Overfitting. So discuss about underfitting. Underfitting. If if model has low accuracy also both both training and test data. That if model has low accuracy, both training and test data. So this type of model is underfitting. Understand? So what we are discussing? The we have the scenario. The model performance well on the training data, but poorly on the new unseen test data. For example, the accuracy of training data is around 90%, and but the test data accuracy is around 50%. That is bad accuracy. So this means model has learned the training data too well but failed to generalize. I- In this case, we say the model has a low bias but high variance. Low bias and high variance. Uh, that is high variance. That's how if the model has a low accuracy on the both training and the test data, this means the model is not trained well. Even the training data even on the training data, the leading to the poor performance overall. Here the model exhibits the high bias and high variance. Right? Understand? The notes purpose. Please write down on your note book model machine learning machine learning model 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 evolution and selection. What we have learned. So in trained data, if model accuracy is low, that is high bias. High bias. If in test data, if model accuracy is low, that is called high variance. Hope all the terminology are clear. What is overfitting, underfitting, test data, trained data, or underfitting, bias, high variance, low bias, all the concept. Hope all the concept are clear till now. The model is underfitting. Underfitting. Consider the training data point you plot on the graph is training data set is plot on the graph is this way, right? And the test data set is also available on this way, right? So, best fit line will go on this way, right? But in overfitting if test data if test data is available this way, but train data is available in this way. So best fit line is go this way. Oh, sorry. What is difference between both the peak? In this peak, this is for generalized model. Generalized model, right? This is for overfitting. Low bias, high variance. High variance. Low bias, low variance. What is difference between both the graph? The difference is that in this graph, the training data set and test data set have accuracy. High accuracy show best fit line goes closely, right? But the test data set is very bad accuracy and the train data set is very high accuracy. So the line is not goes closely, right? This is not the best fit line. For generalized model, both accuracy is high. Test data accuracy and the train data accuracy as well. So hope we are able to understand the whole overfitting, underfitting, training data set, test data set, validation data set, bias, high variance, everything about the video lecture of overfitting and underfitting, concept related to overfitting and underfitting. Thank you for listening and joining us. See you in next lecture.